Hello everyone, this is Harsha from Sri Venkateswara College of Engineering. Today I am here to present you a video assignment on Introduction to the Principle of Inclusion and Exclusion. This is a course of DMA, which is basically called as mathematics. Here we learn the principle of inclusion and exclusion, its fundamental concepts in mathematics and computer science that helps us understand and calculate the number of elements in a set. This powerful principle provides a systematic way to count the number of objects in a collection. Even when there are complex relationships and interdependence between the elements. So the inclusion and exclusion carried out. So understanding the fundamental concepts, the principle of inclusion and exclusion is a fundamental concept in combinatorics, the branch of mathematics that deals with counting and enumerating discrete structures. This principle provides a powerful techniques for determining the number of elements in a set, particularly when that set is defined by multiple conditions for or properties. At its core, the principle of inclusion and exclusion states that the number of elements satisfying at least one of the several conditions can be calculated by considering the number of elements satisfying each condition individually, as well as the number of elements satisfying the combinations of those conditions by carefully accounting for the overlaps and intersections between the sets defined by the various conditions. This principle allows for the accurate counting of unique elements, avoiding the pitfall of double counting or missing elements entirely. So application in combinatorics: counting unique elements, avoiding double counting, solving problems with Venn diagrams. First, counting unique elements. The principle of inclusion and exclusion is a powerful tool in combinatorics, allowing us to count the number of unique elements in a set of accounting for overlapping subsets. This is particularly useful when dealing with complex set of operations like union and intersection. Here you can see an example of union and intersection. This is called as union and this is the intersection example. Avoiding double counting. By applying the principle of inclusion and exclusion, we can avoid the common pitfall of double counting elements that belong to multiple subsets. This ensures accurate counting and helps solve complex enumeration problems in areas like graph theory, probability, and algorithm design. Solving problems with Venn diagrams. The principle of inclusion and exclusions can be visualized and applied using Venn diagrams, which provides a initiative way to represent set operations and understand the relationships between different subsets. This makes it a valuable technique for solving a wide range of combinatory problems. Next, counting unique elements. So one of the key application of principle of inclusion and exclusion is in counting the number of unique elements within a set or collection. This technique helps avoid double counting and ensures an accurate enumeration without overlooking any elements. 10 unique items. In a collection of 10 distinct objects, the principle of inclusion and exclusions can be used to determine the number of unique elements, which are 10 unique items. 3 overlapping sets. When dealing with intersecting sets, this principle is essential for counting the unique elements without counting any duplicates. So, 1. Final count. The inclusion and exclusion formula provides the precise count of unique elements even in complex scenarios with multiple overlapping sets. Avoiding double counting. The principle of inclusion and exclusion is a powerful tool for counting, but it's important to be careful to avoid double counting elements. When working with sets and subsets, it's easy to accidentally count the same element twice. If you are not vigilant, this can lead to inaccurate results and skewed data. To avoid double counting, it's crucial to have a clear understanding of the relationships between the sets you're working with. Visualizing the sets using Venn diagram can be extremely helpful as it allows you to see the overlaps and intersections clearly. By carefully considering the unique and overlapping elements, you can ensure that each element is counted only once. Additionally, it's important to be methodical and systematic in your approach. Carefully tracking the elements you have counted and the sets they belong to can help you identify any instance of double counting with precise and attentions to detail. You can master the art of avoiding this common pitfall and achieve accurate and reliable results. Solving problems with Venn diagram. As you can see the Venn diagram here in the picture, this is called the Venn diagram. Venn diagrams are a powerful visual tool for solving complex problems involving sets and logical relationships. By representing different sets or as overlapping circles, we can clearly identify the unique elements, the shared elements, and the relationships between them. Leveraging Venn diagram, we can effectively tackle combinatorics problems, avoid double counting, and gain deeper insights into the underlying logic. The initiative nature of Venn diagrams make them an invaluable assets in fields like mathematics, computer science, and decision making. So inclusion and exclusion formula. So the inclusion and exclusion formula contains union, intersection, and principle. The inclusion and exclusion principle is a powerful formula for counting the number of unique elements in a set or collection. It works by first counting the total elements across all sets, the union, and then subtracting the number of elements shared between the sets. This allows to avoid double counting elements that belong to multiple sets. The principle is particularly useful when working with Venn diagram and combinatorial problems involving complex set relationships. Practical examples and case studies. So there are three practical. Here we have three practical examples: counting voters, probability calculations, software engineering. One common application of the inclusion and exclusion principle is estimating the size of a population, such as the number of registered voters in an election, by counting for overlaps between different voter categories. Example: Democrats, Republicans, Independents. The true number of unique voters can be determined more accurately. Probability calculations. In probability theory, the inclusion and exclusion principle is essential for computing the probability of the union of multiple events. This technique helps avoid double counting when events overlap, leading to more precise probability estimated for complex scenarios. In software development, the inclusion and exclusion principles can be used to manage dependency between the software components. By carefully tracking overlaps and intersections, engineers can avoid bugs and improve the overall reliability of their systems. Limitation and exceptions. The limitations and exceptions are we are aware of one key limitations is the formula becomes increasingly complex in number of sets involved grows larger. High integrated situations with many overlapping sets, the calculations can become unwieldy and error prone. Additionally, the principle may not apply in cases where the sets are not mutually exclusive or independent, etc. So the conclusion and the key takeaways are In this presentation, we have explored the fundamental principles of inclusion and exclusions, and the principle of inclusion and exclusions, widespread applications in various fields and computer science and mathematics and finance, business analytics. We have looked through all the fields. Key takeaways: understand the fundamental concepts of principle of inclusion and exclusion, develop proficiencies in applying this principle to solve count-based problems, leveraging Venn diagrams and etc. And as move forward, we encourage the continue of exploring inclusion and exclusion through the further study practices and applications to your specific needs by mastering the powerful tools, etc. Thank you. Have a nice day. Goodbye.